Hello, and welcome to the second part of the hands-on optimization masterclass, where we focus on another type of supply chain problem, network design and network optimization. So the next two sessions will be about this. And then in the last two sessions, we will talk about modeling tricks and best practices that you can use when building solvers. So just to recap a bit, until now in the first 8 sessions, we talked about production optimization. And now we are actually going to build on that and create a network optimization solver. So if you want to really understand how network optimization works, you need to watch just the first 4 or 5 episodes of the previous part of the masterclass. And we will also continue using the app made by Felipe Brandao that is here with us. He's from AMPL. Now you already have in the app 4 homeworks, which we talked about in the previous videos. And now we are going to build a different model for network optimization that you are going to use to practice. But as I said, it builds up on the other one. So just make sure you go and follow those videos. So let's see, the agenda for today is that I'm going to explain a little bit about network optimization, what are the concepts, what are the important things to pay attention to, and we are also going to make a little comparison between the network design. Because they are similar problems, but in terms of modeling, we use the same equations, but we have different data, different concepts, and so on. And I think the best way to distinguish them is that the network design is used for strategic planning. So for long term, a lot of aggregation and very high level decisions. Whereas when it comes to network optimization, we are more in the tactical planning horizon, which can be mid-term, like a few months to 18, 24 months. So then, of course, the granularity changes of the data, but also the decisions that you make. So this is what I'm going to explain today. So let's start going back to what is the supply chain problem? What problem are we trying to solve? So it's basically we have a network of factories, distribution centers, and customers. Customers are often outside the network of the company, but for example, when we do network optimization, we consider the customers in the network. And then when we talk about this big network, there are two types of decisions: where to produce. So where should we base our production? And then from where to deliver to meet the demand. So we have the customers on this side, but let's say in the middle we have the distribution centers, and then there needs to be a decision of which customer is served by which distribution center or by which plant, and those are called direct shipments. So I'm going to re-explain this a little bit. Yeah, maybe let me put the hand here. I think I should have skipped to the next one. Okay, so here. Okay. So production optimization, as I said, this focuses on the decision of producing. So what happens is that you do have the customers, but the customers are served by a certain location, a certain distribution center, and you know that. So this is an input. You have the links between distribution center and customers. You have the possible transportation lanes. So this comes as an input in the solver, which means that the demand is on the distribution center, on item location, or it can be on the plant as well. The idea is that the demand is not on the customer. It is decided already which customer gets products from which distribution center. So the only decision that the solver does is where to produce and how to transfer things inside the company, right? Because sometimes you need to transfer maybe from one plant to the other, but also from the plants to the distribution center. that need to serve those customers. So this is essentially the production optimization problem, where we focus on the production decision and transfers stock STRs and STOs between the locations of the manufacturing company. And now if we go to network optimization, this is where the situation changes that the demand has no location assigned, meaning that the granularity of the demand is item customer, and then the solver also decides from where to ship it. So here we have a new type of variable called shipments. So the solver just knows that those distribution centers can be connected with the customers. You can have like all distribution center can all serve all the customers, or you can have lanes to restrict this. But you just insert this data, and this way it's called network optimization. So it's end to end. You have the factories, you have the distribution center, and you have the customers. And then the solver decides everything. Where is best to produce, how to transfer the goods inside your company, and then from which place to ship to the customer, either from the plant direct shipment or from the distribution center. And this way, this is very powerful and very popular because it just solves the problem, a very big problem with all the constraints considered in the same time. So this is the problem we are going to continue talking about. And as I said, it just builds on the production planning solver, because I already gave you a hint. Basically, the thing that happens is the demand. The granularity changes from item location to item customer. And this means the equations change just a little bit, but all the other equations stay the same as the production planning solver. So this is what we are going to talk next week. We will show you the equations, the app, how it changes. But as I told, nothing changes in the other equation, just in the demand. And why is this important? Because the demand is an input. It's the driver of the solver. So then the fact that demand changes from product location to product customer, that's, let's say, the biggest change. And then we also use those shipments as variables, but of course they are connected with the demand. And now let me explain a little bit of what I told you already. What is network design? Because as you know, in planning, manufacturing, we have different horizons. So you have the scheduling horizon, which is very close to the execution part. You have the operational horizon, which can be a few days to a few weeks, where you use a certain type of solver. Then you have a tactical horizon and strategic horizon. And then depending on the horizon, you have different decisions, a different granularity of the data, and then of course, kind of different solvers. But the core of the solver is the same, but some constraints change. If you're in strategical planning, the constraints are very relaxed and focused on certain things. If you're in the operational planning, you have more constraints and they are more rigid, and let's say maybe it takes a bit more time to find a solution. So I will I'll explain a bit about the strategic planning and how the network design is the way to support the strategical planning. So, as it says here on the slide, in the strategical time frame, company needs to take decisions. Should I open a location? Should I close a market? Should I maybe have new products? So this is used a bit like, also you can think of scenarios. What if I have this? What if I have that? And here you have a few examples, as I said, opening or closing a factory or a distribution center, or even a resource like a line in a factory, supplier selection, make versus buy analysis, design of new product networks, and so on. So this is very powerful to decide in which direction do you want your company to go long term. This can be 3 to 5 to even 7 years. And to model this use cases, you use mixed integer programming, which is linear programming, and some decisions are integers or binaries. For example, you have a variable which tells you if to open or not a location. So it's 1 if to open a location and 0 if not. So as we learned in the previous lessons, what happens in the supply chain is like we balance demand and supply. So this part is covered by the linear programming part of the model. And then the integers and the binaries model the network design decisions. Um, Now, what happens with the network design? As I said, it's very long term and it's the strategic decision. So you don't need to have all the data and all the level of detail. So then you aggregate. You aggregate the SKUs in family products, and other similar things. Also resources, have resources groups, customers, they are aggregated in either zones or markets or even regions. And then the bucket is also quite not like days and minutes, can be quarterly or even yearly buckets. And those aggregations are not very easy. This is an issue which happens in most of the projects. People think that the data is ready and we can start the project. So always think, what data do you need? How long does it take to get coherent data and so on? So this is something you should keep in mind for all projects about optimization, that the data cleaning and gathering and organizing takes a long time, more than you always expect. And this is one example here, aggregations, right? Because when you're in a manufacturing process, you have a BOM, right, for a product. But if you aggregate to a family group, you also need to aggregate the BOM. And that is a lot of work. So I would say this is one of the biggest challenges because the modeling is not super difficult here. As I said, it's just a few constraints, not yeah, it's like textbook constraints. But aggregating the BOMs, production rates, transportation lanes, this is a very big part of this type of project. And also what happens is that you also need to build the current state of the network, and this is called the base scenario. And this is what you do. You have the base scenario, and then you have the other scenario where you play with all those options, and then you check what is the difference. Do you gain more money or something else? It's usually cost based. And I just included here an example of the greenfield analysis, um, which is kind of a variation of the network design. And this is used when it's usually when you want to add a new location. So that's why it's called greenfield, that you need to put the location in the middle of a field. And then this has, let's say, a certain constraints. But as I said, this is quite easy to model. What's difficult is the data, aggregating, and also creating the good scenarios and good, like you need to think when I think about strategical planning, what does success look like? What is my company focused on? Am I focused on, let's say, reducing inventory or increasing service levels or other aspects? So this comes with this kind of thinking, data challenges, and the modeling is quite straightforward. Now let's go to the tactical planning. So as I said, this is like a midterm, and the most famous process we find in this horizon is the S&OP process, sales and operations. And this process has several activities, which are demand planning, the rough cut capacity planning, the procurement activities, uh, in and out products, and planning parameters, calendars, and so on. I will maybe talk a little bit about the rough cut capacity planning. This is just a way where they aggregate demand, again, by product families and so on, and they check not even at the resource level, at the factory level. Do we have capacity to meet all this demand for the next 2 years? And after they check this, then this flows down into an MPS process. So again, the purpose is to balance demand and supply, and the first thing you do this capacity, and of course then you need to check the procurement, like can I procure enough raw materials to meet this demand? So those are the two main activities, the RCCP and the procurement activities. And also here, you still have this kind of long-term thinking about what are our financial objectives as a company, how can we achieve our objectives given the demand we have, the resources we have, and yeah, what are potential risks? You can say, like if a line stops, or I don't know, we have a problem with the labor and so on. So here you also analyze this kind of things, but they're a bit more specific, not like with this strategic planning where you look very far in the future. Also in the S&OP process, we have aggregation because we don't need the details of SKU level, resource level, and it's usually monthly bucket. Customers are also aggregated. And this is the solver used to model the S&OP process is the network optimization. So you model the full network, the plants, the distribution centers, supplier, customers, and so on. Also here you need to pay attention with aggregating bombs, rates, transportation, and in my experience, in this kind of projects, the costs are very hard to get the right costs, even for production, for inventory, the transportation, and so on. So this is another part of the project at the beginning, that you need to aggregate the data, make it coherent, consistent, and get the right costs. Because in each part of the company, there are like a different type of costs. In the financial department, they have certain numbers. In the plant, they have certain numbers. I don't know, in the demand planning, they have other numbers. So getting everybody together to sit on the same table and agree on the costs that they use to do this kind of long-term financial decisions, it's quite challenging and time-consuming. So the type of decisions, where and how much to produce, and from where and how much to deliver, what I just explained you in the beginning. So this kind of end-to-end, where to produce, how to move things around, and how to meet the demand to the customers. And as I said, the solver is free to choose everything. Sometimes, for example, in terms of lanes, people restrict it, but sometimes they just say, let's run the solver free and see how would the solver organize the network. So that's how many companies start. And then they start putting restrictions. Maybe we consolidate this, maybe we do some other things. But it's very powerful to see what would the solver choose, and then compare to what you usually do when you don't have an optimization. So yeah, here I also said the main difference is the network design. You have this base scenario, and then you always compare. In network optimization, you need to just leave it open, and then sometimes you do some restrictions. So this is like it's more, as I said, the modeling is the same, like the kind of the same equations, but some constraints are a bit different, and also the data granularity and the way you use it, basically. So it's mathematically is the same model, but it's like, how do you interpret the results? What do I need to results? What do I need to look at? And yeah, it seems like we got to the end of the class. So I just want to make this introduction, again, explain about production optimization and go gradually to network design, network optimization. And in the next class, we are going to talk about the technicalities, as I said, how the granularity of the demand changes and the material balance equation changes a little bit. The rest stays the same. So if you want to understand network optimization, go and watch the other classes. Until next time, you will be ready to follow this one, and you will see it's quite easy. Once you've done the production optimization solver, I'm going to see how to validate results and again compare the two types of solvers, production optimization and network optimization. Okay, Felipe, do you have any comments or questions?
No, I'm just really anxious to see the next session.
Yes, we are creating anticipation. Okay, thank you for joining, Felipe, and I'm looking forward to see the app and not the app. We have the app, the new solver, and I'll see you next time. Thank you. Bye.